What up, your boy C Rizzy coming at you with Unit 9, Lesson 2, Reflections. Our essential question is, how can you represent a transformation in the coordinate plane? And our objective is to find the reflection images of a figure. When you reflect a figure across a line, each point of the figure maps to another point the same distance from the line, but on the other side. The orientation of the figure reverses. This is what a reflection is. So a reflection across some line M, which is also called the line of reflection, is a transformation with the following properties. And it's, again, basically all the properties here are is that rigid motion still occurs. So with a reflection, you preserve size and shape. So the distances between points are congruent, the angles are still the same, okay? And when you write a reflection, okay, you use a capital R, and then in the little subscript, what is the line of reflection? So example, I want to reflect over the y-axis. So sometimes when you see this, you'll see reflection, and then you'll see a little subscript that says y-axis. So here is the y-axis, and I'm just going to draw a little line, just so we see our axis or line of reflection, right? So there's the y-axis. So I want to reflect the point I over the y-axis. So all I'm going to do is I'm going to count to the line. 1, 2, 3 spaces it took me to get from I to the line. So I'm going to do the same exact thing over the line. 1, 2, 3. So that I prime is 3 spaces from the y-axis, and I is 3 spaces from the y-axis. So that is a perfect reflection. Do the same thing over here with the x-axis, except now my line of symmetry is the x-axis, which is here. So now I'm going to reflect over that line. So I do the same thing. For reflections, all you do is count. 1, 2, I'm at the line, do it again. 1, 2, I'm over the line. There is my reflection. Now there are rules, or there are some little tools for if you're not given a graph, and if you're just given the coordinate point, but that'll be given to you at a later time. So in this problem, we're going to graph this triangle, and we're going to reflect it over the y-axis. So first I'm going to graph my points. A is at -3, 4. B is at 0, 1. And C is at 4, 2. Whoopsie. Not the 2. C. Okay, connect the dots. Got my line. I got my triangles. Here we go. Okay, so now what I'm going to do is I'm going to do the reflection over the y-axis. So I'm going to draw my y-axis. I'm going to label my y-axis. Oops. So now here you see that the line or the triangle goes through my line of reflection. So this is where it gets a little bit tricky. So at the end of the day, you focus on each point and you reflect it over the line. So if I start at A, I got to count to the right to get to the line of reflection. So I go 1, 2, 3, 1, 2, 3. Here's A prime. C prime, now I'm not going to count to the right, I got to count to the line of reflection. So for C, I'm going to go left 4 spaces. And then B prime doesn't go anywhere because it's on the line of reflection. So when you're on the line of reflection, the point doesn't move. So when you reflect this triangle over the y-axis, you get it to actually overlap itself. And that's what the reflection would look like. Okay, a quick lesson check on what we just did. Okay, what are the coordinates of H if I reflect it over the y-axis? So H currently, and I'll talk about the little trick here, H is currently at point, what is that, 4, -3. Now, if I reflect over the y-axis, okay, if I reflect over the y-axis, my y value isn't changing. So what happens here is that when you reflect over the y, your xy point now becomes -x, oopsie, -xy. So my new point should be at -4, -3, H prime, and if I did that, 1, 2, 3, 4, 1, 2, 3, 4, H prime is at -4, -3. So what if I wanted to find the coordinates of G reflecting over the line x equals 3? So again, we've talked about this before, you should have learned this in algebra. The line x equals 3 is the line where every single x value is 3. So that's actually, and it's the opposite of the axis, x equals 3 is actually a vertical line where x is 3. So this is the line x equals 3. So G would be 1, 1. And there's no rule when going over an x equals 3 line or any other line, only the x and y axes. So you just do the rule of counting once and over. And lastly, graph and label the triangle if I reflect over the line y equals 4. Y equals 4 is a horizontal line where the y value is always 4, and that's all the way up here. So this just becomes a little bit tricky because I don't have enough room to reflect this whole triangle. So if I wanted to graph over the line y equals 4, if I did this, I know my f value is at -2, -1. So what we could do, part of this is that the reflection point is the same distance away from the reflection line. So if it takes, so I know that my x value isn't going to change if I'm reflecting over this line. So I know f prime is going to be at -2 still. But to get from -1 to 4, you have to go 5 spaces. So when I get to 4, I went 5 spaces, so I got to go another 5 spaces after 4. 4 plus 5 is 9. So f prime is at -2, 9. G is currently at 2, 2. Again, G prime, my x value is not going to change because it's a horizontal line. But if it takes me 2 spaces to get to 4, then I go another 2 spaces after 4, I'll be at 6. And my last one, H, is at 4, -3. My x value will stay the same. But to get from -3 to 4, you have to go 7 spaces. So I'd have to go another 7 spaces after 4. 7 plus 4 is 11. And that's how you would do it if you weren't able to graph it. All right, that's all from me.